Welcome to Secret Squared. I'm Cassie Secret. And I'm Megan Secret, and today we're going to talk about adding and subtracting polynomials. So let's dive in. Now, since we're going to talk about adding and subtracting polynomials today, we have to first know what a polynomial even is. So what a polynomial is, and polynomial is definitely a term that you're going to see more and more of the further that you go into math. So what a polynomial is it's an expression made of several terms. Now, on a prior video, we actually talked about what terms are. Now, terms are something that is made by multiplying several numbers or variables, or it could just be one number or one variable on its own. So for instance, an example of one polynomial might look something like this: 3x plus a 4. Now, I just want to make sure we point out that 3x is an individual term. The 4 is also an individual term. A 4, even though it doesn't have a variable, it's still a term on its own. It could be a variable on its own or a number on its own. It still counts as a term. Now, once we have that plus, since we're combining several terms together, we now have a polynomial. So this on its own is not a term, it's a polynomial. Another example that we could have that might look a little bit more complicated. So in this case, we just have two terms, but we could have as many terms as we want. So for example, I could have 5x squared y plus 6x minus y plus 4. So in this case, there's 4 different terms. Some have 2 variables, some have just 1 variable. The 4 has no variable, but this all counts as a polynomial. Now, when we have these polynomials, you're going to especially start seeing problems where we are going to have to figure out how to add or how to subtract a polynomial. So the question you get will have 2, maybe more different polynomials, and you'll either have to add or subtract. The good thing is, whether it's adding or subtracting, the steps are pretty similar. Now, when we're talking about adding, and we're just going to kind of break it up into 2 different cases. Adding is probably going to be the simpler of the 2, even though they're very similar. For adding, the main step that you are going to do is you're going to combine like terms, which we do have a video on. So if you are sitting here and you've never heard that term before, we really recommend you go ahead and watch that prior video because it's going to help you a lot with this particular step. Combining like terms, it's pretty much you looking at all the different terms. So for instance, here's 4, and you're kind of looking to see which terms kind of match up with another term. And when we say match up, if you remember in that last video, we talked about matching having the same variables and the same exponents. So you could either add it, or option 2, you might have to subtract it. If you have to subtract it because of the subtraction, you're going to have to do one extra step before you can combine any like terms. Now, when you have subtraction, you're going to have that subtraction sign. Now, in this case, before you're allowed to do anything else, you're going to have to distribute the negative, which we'll see exactly what that looks like in our examples next page. And once you distribute that negative, then you're actually going to end up rewriting your problem essentially as an addition problem. And then from there, you're going to be able to combine like terms. So a lot of combining like terms, there are a lot of things with polynomials. And combining like terms is going to be something that shows up again and again. So those are the steps of how to add or subtract, and we'll go ahead and get going with an example. So for adding and subtracting polynomials, we're going to start with 2 examples, one adding, one subtracting. It's actually going to be almost the same problem. The only difference is one has adding, one has subtracting. We're going to work with the same polynomials. So in this case, for the adding one, which again is going to be probably a little bit simpler than subtracting, we have 2 different polynomials. We have the one in red, and we have this one that's in blue. The parentheses are really just there to kind of group it together and show you, hey, here's one polynomial and here's the other one. Now, if you didn't have the parentheses for this problem, it would actually already be just like a combining like terms example that you might have already seen before. So the parentheses, they're just there to signal like, hey, which is what polynomial, what's the other polynomial? For this, because there is no number directly in front of the parenthesis, that means that there's no number being distributed out. Technically, if we can't see a number, it's really an invisible 1 that's being multiplied out. But when you multiply 1 out, multiplying by 1 doesn't change anything. Same idea, multiplying by 1 doesn't change anything over here. So we're actually able to rewrite this problem with just dropping the parentheses. So we have still that 3x squared plus 4x, and we're also going to add that 6x minus 2. And like Cassie said, this turns into just a combining like terms problem. Now, again, if you had a number that was not 1 on the outside of those parentheses, you would have to distribute it. But we don't have to because it is that 1, and like Megan said, multiplying by 1 doesn't change anything. So from here, now this is just going to be a combining like terms problem. So you first of all have to find what your like terms are. Now, like terms have the same variable, so the same letter, and the same exponent. And looking at these four different terms, there's only one pair of like terms. Both of those, one's a 4, one's a 6, but they both have an x to the first power. And just a reminder, those numbers in front do not impact whether or not it's like terms. All that matters is they both have those x's, and it does have that invisible exponent of 1 there. And then from here, that 3x squared, there's not another term with an x squared, so that doesn't have anything to combine with. The green terms, 4 plus 6, now we have 10, and we are going to keep the x, that as we're combining like terms, the variable and the exponents do not change. And then we're going to also drop down that -2. It didn't have anything to also combine with. So again, what we really saw here is that 3x squared didn't have a like term, so we just brought it down. Those terms that were our like terms, we were able to combine those together, and we kept that variable the same. And then the number on its own, again, if it doesn't have a like term, it doesn't change, you just bring it down. And in this case, we're making sure to write our answer in what we call standard form. That's when you have your biggest exponent first, and then you keep going with the smaller exponents to follow. So the far left term, that's something x squared. Then we have something just x the first, and then we have no variables. And so that would be our final finished answer for that first problem. And then switching gears, now we have the same exact polynomials we're dealing with. The only difference is now we're subtracting them instead of adding. Now, what really matters is if you have something on the outside of the parentheses that has to be distributed. Now, the first set of parentheses still just has a 1 on the outside. Like before, if you were to distribute 1, it's not going to change anything. Because when you multiply by 1, it keeps it the same number. So that first polynomial is going to stay the exact same. It's not going to change, so you just get to bring it out of the parentheses. However, once you have this chunk, instead of just being a positive 1 on the outside, we actually have a -1. So we're going to have to distribute a -1 out to the 6x and to the -2, which really means we're multiplying, because that negative is actually going to affect or change the stuff that's on the inside of the parentheses. So the negative really matters. So once we distribute it, like Megan was saying, that -1 times 6x, when you're multiplying here, that -1 is just going to get multiplied by the number in front. So -1 times 6 is -6. The x stays the same. In future videos, we're going to talk about what to do if you're multiplying two things that both have variables. And the last one, -1 times -2, will get you +2. From here, we have no parentheses. We've distributed all those numbers in the front. It becomes pretty much, we'll follow the same steps that we did up above. We're going to combine like terms. And the only thing that's different from here to the previous problem is some of the signs, because we multiply by negative instead of positive. So in the first problem, we had a +6x and a -2, but now it's a -6x and a +2. So very, very similar. And looking at our like terms, we have the same terms we're looking at. All the terms with just an x, those are the like ones. There's nothing else that really repeats. And from here, we have that 3x squared, no other x squared term. So that we're just going to bring it on down. So we still have that 3x squared. Because again, no like terms to combine, it's not going to change. That green term we have now a little bit different. We have a 4 and a -6. 4 minus 6 gives you a -2. We are also going to keep that x. And then the last term is we have that 2 all on its own. It does not have any other like terms to pair up with. So that 2 is also going to come straight down. Yep. And then again, as we're writing it with the biggest exponent first, and then the next exponent all the way down. And that's going to be your final answer. If you were to compare these, you're going to notice they're very, very similar. There's only that small tweak with the negative that made the subtracting a little bit different, but they both have like a 3x squared and some 2 popping up. But that negative, it definitely does matter. It does change the answer, and in some problems, that negative, especially if it's a smaller part of a bigger problem, it's going to affect your answer even more. So for our next set of examples, we're still going to do one adding and one subtracting example. It's going to be a little bit more complicated because instead of having polynomials with just 2 terms, we're going to have polynomials with 3 terms. And the good thing is for the adding, we're going to follow the really similar steps. We have no numbers in front of those parentheses, so really there is that invisible 1 that we're technically distributing or multiplying out to what's inside the parentheses. But again, when you're multiplying or distributing out a 1, it's not going to change anything. So that means we're going to be allowed to take this problem and essentially rewrite it with no parentheses, because there's nothing on the outside of the parentheses that you actually have to distribute. And let me lower that so we have some space. -7 plus 3x minus 4x squared. And then from here, you have no parentheses, you have a bunch of terms listed out. You're just going to combine like terms. So you're going to see which terms kind of match up. So you can go any sort of direction. I'm going to start with, we have a 5x. We want to see any other terms that have an x. This one has x. It's really important that it's just an x. Like terms have to match. We're going to say it a million times, have to match the variable and the exponent. So it has to be just an x, not an x squared. And then next term, here's a number. So I'm going to highlight all of the other just numbers. And then last bits, here are all of the terms with an x squared. So I'm going to highlight those. So those are all of our like terms. From here, you have a few different options. You could pick any of these terms to work with first. Because I normally want your answer written in standard form, so highest to lowest exponent, I'm going to start with the blue term because that x squared is the biggest term. So looking at the blue, we have a negative 3x squared. Just let me write that over here. Negative 3x squared and a negative 4x squared. Negative 3 minus 4 gives you a negative 7. And keep the variable and keep the exponent. Do not change those. And again, we're going to write that one first because standard form, you write the biggest exponent first. And now we're going to look at the terms that instead of x squared, we're going to go one down just to have an x. So those are our yellow terms. So we have a 5x plus a 3x. That gives us positive 8x. And the reason why right here I'm putting a positive is because 5 plus 3 is a positive 8. That's why this was positive. This was negative because negative 3 minus 4 is a negative 7. So whether or not it's a plus or minus just depends on the sign of that coefficient or the number in front. And our last set of like terms is going to be just those numbers in green. So we have a positive 6 and a negative 7. If you combine those, 6 minus 7 is going to get you negative 1. So since it's a negative 1, we're going to put that minus sign. Let me go ahead and highlight that in our green. So we start with 3 different sets of like terms. So at the end, we have 3 different terms in our answer. And just to be really careful, you always want to check and make sure that you can't keep going. In this case, all 3 of these terms, none of them are like terms. So one has x squared, one is x, one's a number, so they're going to stay separate. Now, if you did a step and you get to what you think the end is and you have like terms, you need to go ahead and combine them. So in this case, we don't have any more like terms, so this is our final answer. And now switching gears for subtracting, this one has different polynomials. Thankfully, this first part, we have just really, let me switch this, there we go, really a 1 in the front, so that is not going to change anything for that term. Because again, distributing 1 won't change anything, so we're just going to go ahead and take that polynomial, take it out of the parentheses. This part, the blue part that has that subtraction sign in front, really it's a negative 1 that's being multiplied, so we have to multiply out a negative 1 to every term that's inside those parentheses, but really all that happens is the signs just switch. So we now have a positive, there we go, 6y squared, and 4y was positive, now it's going to turn negative. Because again, what we're really doing is we're multiplying those terms by negative 1. Negative 1 times negative 6, that got me the positive 6 over there. And then negative 1 times positive 4 got me the negative 4. But as Megan said, it's really just understanding that it's going to end up flipping those signs. And then from here, same steps as the adding. You can look at this any different way. I'm going to start left to right. We have a y term, so we're going to see any other terms that also have a y. In this case, this one does have just the y. Now let's look at this next term. We have something with a y squared. There's one other term with a y squared. And I like highlighting or making some sort of marks because looking at this, it's really clear that there is one term left. And because it's the last one left, it doesn't have any like terms to go with. So that already tells us right now that in our final answer, we're going to have just a plus 3 on its own because it's not going to have anything to combine with. And then from here, I'm going to start with the highest exponent, so that y squared, just to put it in standard form at the beginning. Taking those green terms, the 4y squared and the 6y squared, combine the numbers in front. 4 plus 6 is going to get you 10. The y squared is just going to tag onto the end, because that means you have 10 of the y squareds. Yep. And then our next one, I'm going to go to the term with just the y. I have 12y and minus 4y. We're going to combine those terms. 12 minus 4 gives you 8. Because it's positive, it's a plus 8y. Yep. And then the last bit is that 3 is really just dropping down. And it was a positive 3, so it's going to stay a positive 3. Now, so we have, here was our original, no, this was our green term, the very first one. Then the y term, there's our yellow term, and there's our blue term. So this labeling just helps you know where you got the terms from, just in case you're looking at the lines and maybe you can't quite tell where they're coming from. Just a good way to stay organized in your work. And we can double check all of these terms are not like terms. One's a y squared, one's a y, one's a number. So can't do any more combining. So this is our final answer. So for our last example, we're going to do putting it all together. We're going to have 3 different polynomials instead of 2. We're going to have 1 bit of subtracting and 1 bit with adding, just so we see all of it together. Our goal here is to show you that even if the problem has a lot more parts to it, it's still the exact same steps. Yeah, so if you can add and subtract, when you do it in the same problem, you don't have to do both of them at once. You can do bits and pieces. So looking at putting it all together, first things first, this very first polynomial, it doesn't have any number in the front. It's really just a 1 being multiplied. So this ends up being just the 3x squared plus the 5x minus the 2. Because technically when you multiply out that 1, it doesn't change anything. So again, our goal right now is to take all of what we have and to make it look a little bit simpler and nicer, get rid of those parentheses and make it a combining like terms problem. Because even though there's a lot more terms to combine, it's the same steps that you might have seen. So we just dealt with that first polynomial. Our next polynomial, you can't just take it out of the parentheses because there is a negative 1, that invisible 1, and since there's that minus, it's negative. We have to take that and distribute it to our polynomial. So once we do that, negative 1 times 3 is negative 3, and negative 1 times 5x is negative 5x. Once you distribute whatever's on the outside, that's when you're allowed to get rid of your parentheses. So this first polynomial really gave us this. Our second polynomial really gave us this, and now we're going to work on that last polynomial. We are adding that last polynomial. So similar to the first one, there's an invisible 1 in the front. When we're multiplying out a positive 1, we aren't really changing anything. When you multiply by 1, it doesn't change the number. So we end up with a positive 6x squared minus a 4. So here is what we got from that very last polynomial. And then from here, we have we have 7 different terms. Now we're going to start combining them all. So again, it might look more complicated because there's a lot more terms. However, it's the exact same steps as before. You want to start by finding any of your like terms. So like terms, at the very beginning, I have something with an x squared. So now we're just going to look through the rest of the terms and highlight anything else that also has that x squared. Yeah, now at the very end, I have that 6x squared. I'm going to highlight that the same color because those both match with the same x and the x squared. Now our next one, if we look at, we have an x. I have another term right here that is just an x. So those are going to be like terms. And then now we end up with 3 left. We have all of them are just numbers, so those will be like terms with each other. Yep. And again, those numbers are like terms because all of them are the same in that they don't have a ladder. So from here, to put it in standard form at the very end, we're going to start with the highest exponent. So in this case, we have a 3x squared and a 6x squared. Combining those together, we have 3 plus 6. That gives us a 9x squared, because again, when we're combining like terms, we're really counting how many of a certain type of object we have. Now, our object is like the x squared, and we have 3 of them in the beginning, and we have 6 more to add on, so in total we have 9 of them. So we have that light purple done. Now we're going to look at the x term. So in this case, we have a 5x, and we have also a negative 5x. So we're still going to do adding the coefficients or combining them. 5 minus 5 actually gives you 0. So we end up with 0 of those x's, which there's actually another way we can rewrite this in a second. But just for now, we'll leave it with the 0 because we don't have any of them. We had 5 and 5 got taken away. And then the very last part, all of our numbers, I have -2, -3, and -4. I'm adding all those together. So -2 minus 3, you combine those, you're going to get -5. And then subtract 4 off that, so you're going to get negative or -9. And that is all coming from those red terms. And last little bit is technically, if you have 0x, you don't really have to write it. So we can just kind of get rid of that term. We can rewrite it as our 9x squared. So that was still that very first term. And instead of writing that 0x, we just go right to the -9. Because if you have 0 of something, it's not there. So you do not have to include that 0x in your answer. So for us, we're going to leave our final answer as this. Now, just to be clear, you could 100% have what's written above as your final answer. It has the same meaning, it's just the bottom one might be a little more simplified. Yeah, you are not wrong at all. However, us math people tend to want to write as few terms as possible, so we're going to write it this way. Thanks for watching. If you enjoyed this video, please go ahead and like and subscribe. If you have any other topics you want us to look at in later videos, leave them in the comments below. We'll see you next time.